Okay, this is the notes for section 6.1 in Algebra 2. And we're learning how to classify polynomial functions. There's a lot of vocabulary in this section. All right, we're going to start with the simplest unit here. It's a monomial. And there's a variety of things that are called monomials. It can be a real number, such as 4 or 3.2, or even the square root of 5, or negative 5/6. Okay, those are all monomials. There are also constants. In other words, there's no variables involved. But often you have a variable instead, which after all does represent a number, so a variable. And it could be the standard x or y, but you might have a Greek letter like theta, or you might have t. There's a variety of variables used in mathematics. Okay. Or, and this is important, a product. Product means multiplying. You can multiply numbers and variables together. And you can have long strings of these, and exponents come in handy, but the exponents have to be whole numbers. So these are the whole numbers. 0 is the smallest whole number. Then it goes 1, 2, 3, 4, 5, etc. So even though there are such things as negative exponents and decimal exponents, you're not allowed to use them in a monomial. You have to have an exponent of 1, 2, 3, 4, 5, or even 0. Now, I will say that if you have x to the 0, it's just equal to 1. So normally we don't even write x to the 0. Okay, so let's do a product of a real number and a variable. We could do 4x or 3.2y or theta times root 5 or negative 5/6 times t. Yeah, you can have multiple variables. So in other words, long strings, and it's got to be multiplication. You can't have an add or subtract involved. But if I had 2n to the third power, you could write it like this. And you can see that the glue that holds this monomial together, and here's a central concept, is multiplication. So you could think of it as a whole bunch of numbers, or just one number, but a whole bunch of numbers held together with multiplication. So you might have negative 4n squared, or you might have 8t to the fifth power n to the fourth power. So if I wrote that out, it'd be 8, and then you'd have times t times t times t, 5 of those, and 4 of the n's, and it'd be multiplication all the way down. And you might have 2/3 a, b, c to the 6th. And you'd have a times b times c times c times c times c, 6 of them in a row. And times the 2/3. So there's actually nothing but multiplication inside of that internally. Okay, so it's important to know when you're not dealing with a monomial, sums and differences like x plus y or t minus q, those aren't monomials. These are counterexamples. You can't have complex or imaginary numbers. So you can't have 3i times x, and you can't have x times 2 plus 7i. In other words, you can't have I involved. Negative exponents actually make sense, but they aren't allowed here, so this is not a monomial. And you can't have fractional exponents either, so negative 6n to the 2/3 power. There is meaning on the 2/3 power. That's for a different section of the book, but we're not allowed to use them here in the context of a monomial. Okay, switching gears now. We're going to put several of these together here, and we're going to learn to call the string a polynomial. And a polynomial is either a monomial or more than that, the sum of several monomials. Now, the word poly actually is a prefix, or the prefix poly means many in Greek, and so you would expect there to be more than one, but here it's one or more, so a monomial actually is classified as a polynomial also. So I'm going to give you 4 examples of polynomials. This one here, if you wrote it out, is just one monomial held together with multiplication all the way down. But if I take that one and I add another one to it, now that plus sign breaks the string up into 2 terms, and this one's called a binomial. So we have 2 types of polynomials here. So far we have a monomial and a binomial. And you're familiar with trinomials. And one quick way to tell that you're starting a new term is anytime you see a plus or minus sign, you can kind of divide it up into the terms there. So this polynomial is composed of 3 separate monomials, and it would be called a trinomial because of that. Now, polynomials can have hundreds or even an infinite number of terms. I'll do one with 4 terms. Nor are you always required to only have one variable. So, for instance, the binomial in the top right-hand box could have a y there, and it'd still be a binomial. All right, so you can see that we're stringing these together, putting them together with adding. Now, subtraction is just a form of adding. So when I say that we're summing them, that includes subtraction. After all, if you take 10 plus 3, or excuse me, 10 minus 3, you could write it as a sum. It would look like that. So anytime we talk about a sum, we also mean a minus in that context too. Okay, so I'll pick up on page 2 in the next video.